Hi, so we started probability last class. So today we're going to do probability predictions, okay? So when I say probability predictions, what I'm saying is we're going to be given certain information and then we have to make a prediction of what could happen later on. So let's look at what that looks like. Big thing when you're creating these are actually very much stuff we've already done, which is creating proportions. So if you notice, you're going to have a part over the total of whatever they give you, and then you're going to set up the proportion and solve. So if 30 people were surveyed, how many people could be expected to choose strawberry? Well, first things first, you should look here and don't tell me 5, because this right here is not 30. This is 5 plus 2 is 7, 7 plus 3 is 10. So this is only 10 people. So we need to get to 30. So 10 times 3 would get me 30. So 5 strawberry times 3 would get me 15. Now, if you were not sure, if maybe it didn't go nice and easy with your equivalent fractions, you could always do 30 times 5, and you would get 150, and then divide by the 10. So cross multiply and divide. So that's what we're doing today. We're just creating. There's going to be a lot of tables today, just so you know, okay? So the chart below shows the different color marbles Sadie has. If Sadie takes one marble from her bag, which statement about her marble is true? Well, this should say marble right here, so I'm going to change that because that is a typo. But it's saying we're going to have one marble. Okay, so which statement about her marble is true? Okay, so Sadie is less likely to take out a red marble than a yellow. So she's less likely to take out a red marble than a yellow. Is that true, or are there more red than yellow? You notice there are more red than yellow, so she is more likely to pick a red than a yellow. So we're just going to X that out because that's not correct. So I'm just going to, no. Okay, Sadie is more likely to take out a blue than a green. A blue than a green. That is true, so I'm going to put a little question mark there. Sadie is less likely to take out a blue than a yellow. Well, less likely. They're actually equally likely because they're the exact same. So that should say equally likely, so that can't be right. And then Sadie will not take out a green marble. Well, that's not true. That would be a 0% chance, and it's impossible. It is possible to take out green, so it has to be B. So it says the chart below shows the different color marbles Sadie has. If Sadie has 100 marbles, would it be reasonable to say that yellow would be half the amount of green? So when this happens here, we need, what I would do, let's do this. I'm going to make another little mark. What I would do is I would actually say, okay, let me count up first here because I need to see if there's actually 100 here. So 22 plus 16, that's 38. And then 38 plus 8 would get me 46. Plus 4 is 50. Oh, okay. So my total here is actually 50. Well, I don't want a total of 50. I want a total of 100. So what I'm going to do, well, first of all, that's ugly. So let's say that was 50. I want to get to 100. So I'm actually just going to create a whole nother table, another column. So I know that 50 times 2 gets me 100, which means that all of these have to multiply by 2. So that would mean we'd have 44 red, we would have 32 blue, we would have 16 green, and 8 yellow. Okay, so now I can actually answer the question. If Sadie has 100 marbles, would it be reasonable to say that yellow would be half the amount of green? Is yellow half of green? Yes, yes, that is reasonable to say that yellow is going to be half of green. So then here's another question. Would it be reasonable to say that red and blue would add up to 64? Well, red and blue, if I have 100, that would be 44 plus 32. right here. So that would be 76. Uh-oh. That's 76. So is it reasonable to say that? No. It would actually be 76. So this is my suggestion. When you have a table and it's asking you for more marbles than you actually have, so we only had 50 and it's asking us to go to 100, I would actually just rewrite on the column right here. I would add another column to it and put my numbers in for 100. Okay, that's what I would do. Okay, so this one says the table shows the ice cream preferences of 30 people. So let me count this really quick and make sure. 7 plus 5 is 12. That would be 18. And then 18 plus 9 is 27, plus 3 is 30. Okay, good. So it does say 30. That is correct. It does say 30. That is 30. What is the probability that one student selected at random does not prefer chocolate ice cream? Does not. Well, we know that for chocolate there's 6. So 30 minus 6 would be 24. So we would say this is 24 out of 30. So 24 out of 30 do not prefer chocolate. And then we would divide this down. So let's try 2, because they're both even. 24 divided by 2 is 12. 30 divided by 2 is 15. And then I'm like, oh wait, I could divide by 3. Divide by 3. And I would get 4/5. 4/5, which would be 80%. So it is very likely that people do not prefer chocolate ice cream because that's 80%. That's called the complement. Remember, that's the complement of chocolate ice cream. Okay, so here's a spinner. If you spin the spinner 52 times, about how many times will it land on B? Well, so when I have to do a question like this, I have to decide, okay, if I spin it once, how likely is it? Well, there's 2 B's, so 2 out of 1, 2, 3, 4, 5, 6, 7, 8. So there's 8. Now, 52 is the total amount, so there's 52 times. And I don't know, 8 times 52, there's probably something, 8 times 5 is 40, 8 times 6 is 48. So it's not going to go in really nice and pretty. So what I'm going to do is I'm just going to cross multiply and divide. 52 times 2 is 104. 52 times 2 is 104? Yes, okay. I had to double check my math. And then I would divide by what I haven't used yet, so divide by 8. 8 goes into 10 one time with 2 left over. Bring my 4 down. Ooh, yay, it's nice and pretty. 8 times 3 gets me 24. So about how many times is it going to land on B? 13. It's going to land on B 13 times out of 52. Okay, so once again, okay, so is this the same spinner? Okay, cool, that's the same spinner. Awesome. So we're still spinning it 52 times. About how many times will it land on A or E? So let's see, that's 1, 2, 3, 4. So 4 out of 8. Wait a minute. Wait, 4 out of 8 is equal to half. You can always simplify down before you make your proportion. That's totally okay. Well, so then wait, if half the time it's going to land on A or E, well, half of 52 is 26. Or you could cross multiply and divide. 52 times 1 is 52. Divide by 2, and you'd still get 26. So about how many times is it going to land on A or E? 26 times. Right? 1, 2, 3, 4. Okay. I'm always double checking my work. Oops. Oh, okay. Woo, that's a lot more. Okay, if you spin the spinner 160 times, how many times can you expect it to not land on the letter C? So anything but C. How many times can you expect it to not land on the letter C? Well, that's 1, 2, 3, 4, 5, 6, 7 out of the 8 times it's not going to land on C. And then we're trying to figure out of 160. Now I'll tell you, there is an equivalent fraction here pretty easily, but if you don't see it, then you need to cross multiply and divide. And I'll talk about what it is in just a second. 160 times 7, that's 0, 2, 4. Seven times 1 is 7, plus 4 is 11. And then you would divide that by 8. Uh-oh, I'm starting to glitch a little bit. So 8, and then you'd have 3 left over. 2 comes down, 8 times 4 gets me 32. Exactly. So this is a 0, so it's got to be a 0. 140 times. So out of the 160, it's going to not land on C 140 times, which makes sense because C is only this one little piece, so it makes sense that it would not land on it a lot. Now, I said there was another way to do this. You could have done 8 times 20 gets me 160, so 7 times 20 gets me 140. Okay, of the last 14 people at the carnival, 7 people won a prize. Considering this data, how many of the next 16 people would you expect to win a prize? Well, we know 7 win the prize out of 14. And we know that there's going to be 16 people that are playing, so how many are going to win a prize? Hopefully you looked at 7 out of 14 and said, oh, that's 1/2. If you didn't, that's okay. You could do 16 times 7 and divide by 14. So if you didn't have this piece here, but I know that 7 out of 14 equals 1/2. So I'm going to say I multiply by 8, I multiply by 8. And that makes sense because half of 16 is 8. So 8 people will win the prize. You can always you can always like do butterfly to see if that's actually true as well. Ernest has pulled 12 marbles from a large bag and 4 of them are red. So he pulled 12 marbles from a bag, 4 are actually red. Based on the experimental probability, how many of the next 30 marbles selected should you expect to be red? So it's pretty much red over the total. We know that there's 4 out of 12. And we know that they're going to pull 30. So you could simplify and then do equivalent fractions, or I could just multiply 30 times 4 and I get 120. And 120 divided by 12 will get me 10. So 10 of them are going to be red. Okay, last question. A bag contains 4 cars, 3 bubbles, 2 markers, 6 marbles. An item will be drawn from the bag and replaced 45 times. This part of it being replaced, that means that the fraction is always going to be the same. What is the reasonable prediction for the number of times a car or marker will be drawn? So car or markers, that would be 4, 2, so that's 6. Out of, let's see, the total, 7, 8, 9. So out of 15. Because there's 15 total things, and I'm going to draw 45. So I could cross multiply and divide, or I can look for this pattern here. This is a 4, just so you know, it's just really ugly. 15 times 3 gets me 45. So 6 times 3 would get me 18. So what's the reasonable prediction for the number of times a car or marker will be drawn? It'll be drawn 18 out of the 45 times. Grades are going to be due on Friday, so please make sure you check your grades. Complete all missing work. Make sure your corrections are done. Dreambox, and then this is also the code for today, WP6 on IXL. Make sure you get your stuff done. Make sure you're not missing any work, and have a great day.